So this was my senior project that I did as a sustainable living student at Maharishi University of Management. I basically was trying to see whether it was possible to make biofuel from algae in basically a financially feasible way. And so I started researching it, and I decided that I wanted to design the reactors in which algae is grown. And so I experimented with those a little bit. Algae is made out of carbohydrates, proteins, and lipids, which are oils. And in terms of biodiesel, we want the lipids. And so what I was looking at was growing algae further lipids. This is one of my original visions for a photobioreactor. It has a reflector in the back, and it has a tank underground, and then it has where the algae actually gets sunlight above ground. I was really into putting tanks underground because you don't have to put as much energy into heating them or just regulating temperature. This is the first one I actually made. The tank is several feet underground, and it has a compressor that pumps it up, gets sunlight, and goes back down. This is it from the side. The vertical column above the tank actually is insulation, so less temperature variation. And so I made this, and it needed a solar panel to power itself, and the solar panel would take far more energy than the algae would ever create because it needed to get pumped up something like 14 feet. And so I decided to change the design. And so I came up with this, which is parabolic reflectors that feed down through light tubes into the actual tank itself. So that's just a side view of it. There's also insulation above it. And this is my model that I made of it, and just to see what it would look like, see what changes I wanted to make to it. Here are the dishes though, just to zoom in on them. This was the final design that I came up with in terms of a photobioreactor that's underground. The light column rotates constantly, because the light is fed in through a parabolic reflector down through the light column, and then it kind of has a beam of light that just flashes the algae, because I found out that algae just needs a flash of light and then 6 seconds of rest, approximately. And so I decided to optimize the light. I did this design, and it's also attached to an impeller, so it gets agitated. I saw the big problem in the dead zone in the Gulf of Mexico, and I thought it's caused by algae. It's a massive algae bloom from all of the fertilizers that go down the Mississippi, and I figured if it's all algae, maybe it can be harvested. So I started designing different methods of capturing that. First, I designed this really inefficient, giant underwater capture device that has a semi-permeable membrane, kind of just a shaft, and it, with the tides, pushes the water through, and hopefully the algae gets collected in semi-permeable membrane and is harvested above the water. This is a rendering of it underwater, and it also has turbines in it for hydroelectric power, but I thought that was way too expensive and way too complicated. If you make it too expensive, there's no way that anybody is going to build it. And so I came up with this design, which is just like a little kind of horizontal buoy that just collects algae in a semi-permeable membrane, and then people just come along in boats and grab it. The whole theory with this is you're taking the fertilizers which are from the corn production that we're using for ethanol, which is a relatively inefficient system, and we're harvesting it back down in the Gulf of Mexico and to extract the lipids and turn that into fuel. I think it's worth looking into. That was my design process for my senior project. Thank you.